the last lesson for Unit 5 is going to be on applying everything that we have already used so far. So we're going to be solving log and exponential equations. So solving log and exponential equations. Okay, so we're going to start out with log equations. And just a quick reminder, if we look at forms, so if we have log base b of y, and that's equal to x, if we wanted to switch this into exponential form, our base is b, so this would be, have a base of b. Logs are equal to exponents, so x is our exponent, and then that would equal y. So just a quick review of conversions there. So our first example, we're going to take a problem, or it's going to be log base 5 of x minus 9, and that's going to be equal to 3. So if we're solving this, we can't do anything to get the x by itself right now. We can't just add the 9 over because it's inside the parentheses and makes this a part of our log equation. So what we're going to do is we're going to change forms because logs and exponentials are inverses of each other, so there's no way to solve them without doing the opposite. So we're going to take our base of 5, because this is a log base 5. Logs are equal to exponents, so our exponent is 3, and then that's equal to what's left over, which is x minus 9. So we've switched this log equation into exponential form, and now we can solve. 5 to the third power is 125. Set that equal to x minus 9, add 9 over. That'll work for me. Add 9 over, and so I get 134 is equal to x. So that's it. Let's do another example of a similar problem. Let's do a second one. Let's take log base 7 of x plus 3 and set that equal to negative 1. So again, same thing here. We have an x plus 3 in parentheses. We can't do anything with that. So we're going to take 7, change forms here, exponential form, 7, base is 7, to the exponent negative 1. And we've got x plus 3. So we'll solve that 1 over 7. Remember, a negative exponent changes that to a fraction. And set that equal to x plus 3. When we solve that there, we're going to subtract 3 from both sides. So we're left with negative 2.8571 is equal to x. All right, so we're going to take a look at another example now. This time it's going to be a little bit different. So if we look at one that has, let's take log base 2 of x plus 8 equal to 7. Now notice that what's different about this problem than the other ones that we've been doing is the x plus 8 is not in parentheses. So when this is in parentheses, it's all one term. Right now it's not. So the log base 2 of x is one term, and we need to get this log, isolate the log. We need to get the log by itself on one side of the equation. So right now, we need to move the 8 over because we cannot switch forms the way that it is right now. So if we move that 8 over, too much. Once I move that 8 over, I'm going to subtract 8. So I have log base 2 of x is equal to negative 1. Now I can change forms. 2 to the negative first power, because my base is 2, logs are equal to exponents. Set that equal to x, and get 1/2 is equal to x. Because that negative exponent is going to make that a 1/2. Similarly, if I have a problem like this, if I have another example, let's go with 2 log base 5 of x, 4x. 4x minus 7, and we want to, again, get that log by itself, but this 2 is not a part of that. So we're going to divide everything by 2. So we have log base 5 of 4x minus 7, set that equal to 2, change forms here. So we've got 5 squared is equal to 4x minus 7, so 25 is equal to 4x minus 7, add the 7 over, and we got what, that 32, and And so x is equal to 8. And I don't know why the smart board's being goofy, but x is equal to 8. There. We're going to look at some log problems that are involve a little bit of condensing before we solve. So if we look at this first one here, we've got log base 9 of x minus 10 plus log base 9 of 8 is equal to 1. So in order to switch forms, we need to have one log. We can't switch forms when there's two, so we're going to just condense these. Now addition, if you remember, means that we're going to multiply. So if we multiply these together, we've got log base 9. It only works if the bases are the same, and they are. And then I'm going to put the 8 first just because I prefer to put that first. So 8 times x minus 10. We just took what was outside, our resulting pieces, our x minus 10, our 8, we multiplied them together, so that equal to 1. So I'm going to distribute those. Log base 9 of 8x minus 80, and set that equal to 1. And now I'm going to switch forms. So I have a base of 9, my exponent's 1, set that equal to 8x minus 80. And then I'll add the 80 over. So I have 89 is equal to 8x, divide by 8. So x is equal to 11.125. We've got log base 9 of 3 minus log base 9 of x plus 6 is equal to 2. So now we have a subtraction sign, which really means that we're going to divide. So when we do this, we're going to combine these log base 9 of 3 over x plus 6. Remember, that just means division. Subtraction means division, equal to 2. And now we can switch forms. So 9 squared, because base is 9, logs are equal to exponents, equals 3 over x plus 6. I'll solve that and get 81 over 1, because I want to cross multiply here. So when I cross multiply, I get 81 times x plus 6. You can multiply that through if you want, but I'm not going to. I'm just going to go right ahead and divide by 81 now. 81. So I have x plus 6 is equal to 3 over 81. And then I will subtract the 6. So let's go. X plus 6 is equal to 0.0370. Subtract 6. I get negative 5.9630. Log base 6 of 4x minus log base 6 of 2 is equal to 2. Well, the subtraction means I need to divide, so log base 6 of 4x over 2, and log base 6, 4 divided by 2 is 2x. So you can always simplify that if you can. Now we'll switch forms. 6 squared is equal to 2x. 36 equals 2x. So x is 18. All right, let's do one last. So if I've got log base 7 of 4 plus log base 7 of 4 minus x squared is equal to 1. Cool. Log base 7 of 4 times 4 minus x squared. I'll multiply that through. Log base 7 of 16 minus 4x squared. 7 to the first power equals 16 minus 4x squared. Add the 16 over, subtract the 16 over. So if I subtract 16, I get negative 9 equals negative 4x squared, divided by negative 4. So I have 9 over 4 is equal to x squared. When you take the square root of something, that means that you're going to have two answers, plus or minus. So finally, I'll have plus or minus 3 halves. So please notice that you have 2 solutions, because you started with an x squared. The fundamental theorem of algebra says that if we have a degree of 2, we're going to have 2 solutions.